Hello friends, welcome to another tutorial in digital image processing. In this tutorial we'll talk about pattern recognition. Pattern recognition is the foundation stone of face recognition, which is perhaps the most important and widespread application of pattern recognition. It is supremely important to understand pattern recognition and some of the systems which employ pattern recognition, how to design a system for recognizing patterns, and so on and so forth. In this tutorial, we'll talk about the basics of pattern recognition. A pattern is an arrangement of descriptors. The first key point or the sentence that describes the definition of pattern recognition is that it is an arrangement of descriptor. Now, please understand, whenever we talk about a pattern, which is the key term of the tutorial, it is also known as an object at times, and it is an arrangement of descriptors. Now, descriptors can sometimes be referred to as features. So we'll talk about features in this tutorial and in the coming tutorials a lot, because features are what makes up a pattern. The arrangement of those features will make up a pattern or an object. We'll talk about very famous example of a flower with petals of different sizes. The second line of definition says a pattern class is a family of patterns that share some common properties. So the next keyword will be pattern class. So I'm underlining the keywords. The first keyword that we understood was a pattern. Of course, it is arrangement of features, and a pattern class will be a family of patterns that share common properties or features. And this will become more clearer when I put forward an example. Pattern classes are denoted by omega 1, omega 2 and omega w, where w is the number of classes. So we'll talk about that as well. And pattern recognition, what is the process itself doing? The process, pattern recognition is a process itself, is defined by recognizing a pattern by machine that involves techniques for assigning patterns to their respective classes, and that too automatically with as little human intervention as possible. So we'll talk about these features in detail now. Now please understand, when we say patterns are arrangement of descriptors or features, this keyword becomes supremely important, because features are what are going to make up a pattern. Now there is an example of very famous example of a flower with three different types or three different breeds. So we have this example here. Now there is a flower iris that has three different types: Iris virginica, Iris versicolor and Iris setosa. Now these three different types of flowers have different petal size. So if you look at the petal of the flower, its size is going to be different. So based upon the petal width and petal length, which become two features. So if I talk about the pattern of the types of the iris flower, I've defined this flower using only two features, which is petal length and petal height or width. Now, just by taking two features or two descriptors for a flower will give me a two-dimensional space. And when I start to measure the petal size for different types of iris flowers, what I get is that Iris virginica has the maximum length and maximum width. So I take up different petals of Iris virginica and I plot this on this two-dimensional graph with two axes, petal length and petal width. And similarly, I take up the petals of Iris versicolor and it gives me a smaller petal length and a smaller petal width as compared to Iris virginica. And this two-dimensional space is known as, this entire space is known as the feature space. Again, a very important key term. So you can put a star next to it. So this is a feature space. And measuring the features and drawing it on the feature space will give me data points. All these small little triangles, squares and circles are data points. So the first key point is feature space, and then we have data points. Now when we measured the petal length of Iris setosa, it was very small as compared to the other two types. So it had a petal length of almost 2 centimeter, 1 centimeter to half a centimeter, not even 1 centimeter width. So you can see that this becomes one class. So I've mentioned pattern class here, which is a family of patterns that share some common properties. So Iris setosa becomes one class of patterns, and you can see that Iris versicolor is again one class of patterns, and Iris virginica is also one class of patterns. But these circles are known as class regions, and approximating with these two features, petal length and petal width, we can surely isolate an Iris setosa from the other two types, but we cannot isolate Iris versicolor from Iris virginica because their class regions are overlapping. So that becomes a problem area. Of course, we can approximate it using Euclidean distance and so on and so forth, but the mean Euclidean distance, we can formulate the mean area of the petal and then we can approximate it. But just by looking at these two features, can we get to a short solution to the recognition problem that whether it's Iris virginica or Iris versicolor? The answer is no, because of this overlapping region. And what could be the possible solution for this problem? The possible solution is increasing the feature set. So that is why we say when the number of features of a pattern increases, it becomes more easier to recognize it. So super important point, increasing the number of features or descriptors to recognize a pattern will surely help in making the system more robust. So what do you think more features can be implemented in recognizing a flower's petal? It could be the petal color, or it could be the petal area, or it could be the angle between the angle between the length and the breadth of the petal. So just by increasing the number of features, we can make distinct classes of patterns. If the classification of patterns is not distinct enough, we say that the system has failed somewhere, or the system is not 100% accurate system. So pattern classes, in this case we have three pattern classes. So w1, w2, w3. W3 could be thought of as an isolated class, which is pretty good, but W1 and W2 could pose some problems, so we need to add up features. And similarly, if we take up one more example of pattern recognition system, we could see a system where uh, boys and girls, they need to be separated, or they need to be segregated based upon some feature set. Now if we take up just the basic uh, one feature set, which is weight. Now for example, I say that I have a class, the weights of boys are 40, 45, 50, 48, 38, 41, and in kgs of course. And then weights of the girls in a class are 37, 39, 41, 32, 31, 33. These are random numbers. So if we want to segregate, or if we want to classify the patterns in a class, and that classification is of course segregating boys from girls, and we take up only one feature, which is weight, then we'll get up a feature space, which will be a straight line. And of course on that straight line we'll have 31, then 33, 32 of course is also there. So in other words, we'll get girls featuring on one side of the feature line, and boys on the other side, and some area of overlapping, and this region is overlapping because if you look at this value 41 and 41, it features for both girls and boys, and then 38 is one such area which could overlap with 39 or 37. So what could be the solution of this problem? The solution of this problem is adding one more feature, which is, let us say, height. So if we take up height as the second feature for classification of this pattern, then we'll have w1 to be represented as 40, 150, let us say in centimeters or whatever the value is. Then two features will describe one person, or one object in the class of pattern, and this will result in a more diverse feature space, which will be two-dimensional in nature, of course, with again height and weight, as we see in this previous case of the flower, and that will give us a more distinct view of classes. Of course some overlapping could be there, but that can again be cured or rectified by adding more features. And then we could add a feature like a third feature that could be added is complexion. And but if we try to add a feature like number of eyes, that will not help. So this feature is not what is going to help us in classification of patterns or in recognition of patterns. Of course, if we take up more complicated features like the size of the eyes or so on and so forth, that could help later, but just the number of eyes feature, which is a pretty broad feature, so as to say, will not help us in identifying the pattern. So we need to design a system or a machine that will automatically assign a pattern into its respective class. So this is what this definition says. This machine involves techniques for assigning the patterns to their respective classes automatically without or with little human intervention as possible. So this is how pattern recognition system should work. It works on descriptors, which are features, and we need to sensibly and with common sense, we need to add up more and more features so that machine learning is fast and the recognition process is more accurate. And I hope this tutorial was help, and I'll see you in the next video where we'll design a pattern recognition system. It will be a small pattern recognition system, but we'll design it though, and that will make it more clearer. Thank you so much for watching the video. If you liked the content, give it a thumbs up. I'll see you in the next video. Take care. Bye.